Instruction cycle. What is the meaning of instruction cycle? Earlier we have seen how to obtain the instruction. Again, what is the use of the cycle here? So that cycle is going to represent the entire process when we are going to obtain the instruction and when this particular instruction on the basis of which type of the opcode is there and when this micro operation will be completed, that entire thing is coming under the instruction cycle. Okay. So here again we have instruction cycle for the register interface, memory interface, that all discussion will be there for the input output interface. So inside this instruction cycle we'll see about register interface, and for the memory interface we'll have separate topics that we'll discuss separately. Okay. So let's start with instruction cycle here. If you didn't subscribe our channel, please subscribe it. Okay. So in case of basic computers, this machine instruction, what we are seeing here, is being executed with the help of following 4 steps. Mainly we have 3 steps that we call as the fetch, decode and execute. But we can consider 4 steps also. So in the fetching, what is happening here, we are going to obtain the instruction from the memory. You know that instruction, everything is stored in the memory. So after fetching, you are going to obtain the information from the memory, and that will be where in the instruction register. Okay. And after that, getting this IR information, so that having 16 bit for the basic computers, we are considering here 16 bits of the instruction register. So from this 16 bit, we have seen that first 0 to 11 bits are the address bit, 12 to 14 are the opcode, and 15 is the I, that's going to denote that it is either direct or indirect addressing mode. So on the basis of opcode, we are going to decode. Okay, we are going to decide which type of the instruction, which type of the operation will be performed here. That is the decoding. So if it is the indirect address mode, that is going to be decided by the 15th bit. Then we have to read the effective address from the memory. Okay, in case of indirect address. Direct address means then this third step is not required. Directly we can reach to the operand. And last one is the execute. So whatever micro operation is given, so that will be executed between the contents of the accumulators and the data registers. So we'll have ESE and data registers. So this data registers contents also we are going to obtain from where? Memory. That operand will be stored in the data register before the manipulation. Once instruction is executed, again this cycle will start from the step 1. So this is being repeated. Okay. For the next instruction. But different processors having different ways. So every different processor has its own different instruction cycle, but this is the for the basic computers, fetch, decode, and execute. So this instruction cycle is very important question also. So here now we are going to see how fetching and decoding is going to takes place. For that, we are going to take the help of different types of the registers here. So first of all, we have whatever information we are going to obtain or that instruction set, that will be where in the instruction register. So here we have a structure of the common bus. Okay. So again, the operation of the common bus is being decided by the S0, S1, S2 combination. So inside this common bus, earlier we have seen how we can design the common bus. So that common bus is being designed by the help of multiplexer or by the help of tri-state buffer. Okay, these are the provision by which you can design either by the help of multiplexer. So here we have multiplexers. So the having 3 selection lines means here we have 8 ports in the input and 1 output. Already you know that multiplexer will give 1 output here. So this combinations of the selection line, this 7 means this is the 111 selection line combination. 1 means 001, 2, It shows 0, 1, 0, 5. 5 is what? 1, 0, 1. So when this selection lines combination is 7, then what will happen? Memory will be enabled. When 1, address registers. When 2, program counter. When IR will be enabled, when it is 5. Okay. Any doubt is there? You write in the comment box. So finally, you see in the connection here, is selection line having OR gate 3 input, OR gate is here. Whereas T0 is connected only to the, if you do the numbering here like 1, or if you write 0, 1, 2. So T1 is connected only to the number 1 OR gate, whereas T1 is connected to the both number 2 and number 0 OR gates. And here in the input side, T0 is connected to the address registers, whereas T1 is connected to the memory side here, as well as here if you see that program counter, okay, as well as instruction registers. So now how this operation is going to happen? And address registers, that address is going to communicate only with the memory, so that you can see here clearly. Now how, when this address will be transferred, or when this address register will be loaded, or when there will be the increment in the program counter. So this all being decided during the timing cycle. So already we have seen about this time and control. Okay. So the purpose of the program counter is to be ready with the address which is going to be executed next. Okay. So here we'll have increment in case of program counter when selection line combination is 2. And when instruction register will be loaded, for that again we have to see the combination. We have 1, 0, 1, that is the 5. So timing cycle, that means clock pulse is also available. If control is not enabled, that loading will not take place. So that is LD is yet for the load. So now here we'll see one by one for the particular timing cycle what is going to happen. So in the initial stage, this program counter is loaded with the address of the first instruction. So that when we are going to obtain the instruction from the memory, so that what is their address 0 to 11th bit by this PC is being loaded. And sequence counter is the cleared in the initial stage and is going to provide the timing cycle T0. We have seen earlier about the timing cycle. So when we are positive with clock pulse, that time this timing cycle T0 will be available for the 1 clock pulse, as well as sequence counter is going to be clear. So during T0, the contents of the PC is transferred to the address register. And only address register can communicate with the memory. Okay. Next, during the time cycle T1, the contents of the memory, the which was that address given to the memory, that contents is being transferred to the IR. IR is the instruction register. At the same time, program counter will be incremented by the 1. Okay. Again, during the time cycle T2, now the instruction register will be decoded. So that we have seen that these 3 bits, 12, 13, 14, those 3 bits are given to the decoder. The decoder size is what? 3 cross 8. So on the basis of the decoder output, it will be decided which type of the operation will be executed here. Okay. So fetching, now it is happening decoding. And finally here, the contents 0 to 11 of the instruction register, okay, is given to the AR if it is the direct addressing modes, okay, or indirect addressing modes means we have to find the effective address. So that instruction register, that address is given to AR to find the operand value. If this 15th bit of the instruction register is 1, it is the indirect addressing modes, then you have to find the effective address. If it is the direct addressing modes means if I value is 0, then directly we can obtain. So these are things are happening in the same time cycle T2. These three operations, decoding of opcode, and this is the transfer of the address of the operand. Again, it is going to check this is given to as flip-flop directly. 15 bit is given to flip-flop directly. So finally, operation during the timing cycle T0, what we are seeing that it plays the PC content to the bus. With selection line should be 2. If 010, then PC content will be given to the bus. Direct PC and address register is not going to communicate them, right? So the common bus one is going to communicate. So it is given to the common bus, and this transfer of the common bus to address register will be takes place if load is enabled. So that you are seeing that load is also connected with OR gates, and here this OR gate is connected to the T0. So how this timing cycle is going to control the entire operation. Again, during the time cycle T1, what is happening here? So it's going to enable the input of the memory. Now, input of the memory will be enabled. Then means memory is ready. Now with this, we can perform the operation. So this here read operation means we are trying to retrieve the information which is given at the address to the address registers. So now this contents of the memory is given to the bus when selection line is the 111. Okay, so first PC given the information to the bus contents will be given to address register, and address register is seeking that contents from the memory unit, and memory unit is going to throw to the control bus. Okay, so these are the control with the help of selection line and timing cycle. Now transfer of content of bus to the instruction registers by enabling the load again, and at the same time PC is being incremented, okay, by enabling I and R. So I and R is what here? Increment. So this is happening during the time cycle T1. So that we have seen here in the short form. Same thing explanation takes place here. This is during T0. This is happening during the T1. Next, what is happening during the T2? Okay, so that what happened here? Decoding, and again operand is being obtained. So all this takes place during the T2. Once this execution will take place, again sequence counters will be clear and it will start with the T0. Now determine the type of instruction. How we are going to decide it is the which type of the instruction. So earlier we have seen that when we have memory reference instruction, so this 0 to 11 bit is going to give the address of the operand. And this opcode 12, 13, 14 bit is going to decide which type of the macro operation will be takes place, and it is given to the decoder. And 15 bit is going to decide it is the direct addressing mode if it is 0, and if it is 1, then it shows the indirect addressing mode. Whereas in case of register reference instruction, so here address is not required, right? So this 0 to 11 bits can be used for the testing purpose or for the some other operation like clear and all these things that we are going to see. And here, in case of memory reference, this opcode combination will be 0 to 6. Okay, total 7 combination will be there. And in case of register reference, this opcode bits 12, 13, and 14 bits must be 111. That is the equivalent to what? 7. And 15 bit is 0. So when 15 bit is 0 and this D7, okay, later we are going to represent this one with the help of D7. If D7 is high and 15 bit is 0, then it shows that register reference instruction. Similarly, this 0 to 12 bits is going to utilize for the input output operation. Your address is not required since we are not going to communicate with memory. Whenever we are communicating with memory, then only address is required. And 12, 13, and 14 bit is fixed. That is here D7. Okay. And 15 bit is 1. Then only we will say that it is input output instruction. Now, how this is going to happen? Okay. So here you are seeing that contents of the memory is being transferred to the address register. So here what's happening? D7 is complement. That means D7 is not 1. D7 is what here? 0. And here I. I is what here? 1. If I is 1, then direct addressing mode and time cycle is T3. So if all these three conditions is going to match, then contents of the memory is being transferred to the address register. If you have D7 dash means again it is the not 1, that is the 0. I dash means what we have here. This is happening direct addressing mode and indirect addressing mode. Okay. Again here we have complement. So that complement and T3. So T3 timing cycle is there. So during this, nothing is going to happen since D7 is not 1. Okay. D7 is not 1 here. And what we have in extra thing, what here? I dash. So this is the way how we are going to control the operation. Now next what we are saying, D7 is 1. Now I dash means it shows the 0. I dash will shows the 0 and I will shows the 1. Okay. So in the previous case, if I is 1 means what is that? Indirect address. Okay. And I dash is the direct address. And here D7 I dash T3. So D7 is 1. I dash means it is 0, 0 and T3. So D7 is 1 means only two possibilities that either it is the register reference instruction or input output instruction. So if D7 we know that it is 1. Now we have to check the I. If I is the 0, that is the I dash, then we have register reference instruction. If I D7 is already 1 and I is the I, this shows the 1. Okay. So finally, it is what? Input output instruction. And this time cycle is what? T3. So here, that things we can see here in terms of flow chart. So in the starting sequence counter is cleared. So that is set to the 0 here. During the time cycle T0, contents of the program counter is transferred to the AR. During the time cycle T1, contents of the memory is transferred to the instruction register. At the same time, program counter is being incremented with the next address, which is going to be the executed. And here during the time cycle T2, decode operation takes place. That 12, 13, 14 bit of the instruction register is being decoded with the help of decoder of the size 3 cross 8. And finally, the contents, what is available in the instruction register 0 to 11, that is the address bits, is being transferred to the address registers. And finally, this 15th bit of the address register, that is, sorry, instruction register is transferred to the flip-flop directly. So this I will be 0 means direct addressing mode, I is 1 means indirect addressing mode. Now, we are going to decide on the basis of D7. In case of memory interface, what we have seen, D7 is not 1, it is the 0, since we have counting there from 0 to 6. So if D7 is 0, it shows that we have memory reference instruction. Again, if it is the memory reference instruction on the basis of D7, then we are going to check the 15th bit, that is the I. If I is 0, that is the direct addressing modes, then nothing we have to do. Automatically, we are going to get the operand at the particular address which is stored. No need to find the effective address. Okay. So that is situation of second one here. If I is 1, that is the first one. If I is 1 here, so then what is happening here? Contents of the memory is being transferred to the address register during the time cycle T3. And finally, execution will take place between the memory reference instruction and whatever contents are there. So after execution, again sequence counter set to the clear. Whereas if D7 is not 0, it is 1. So now here two possibilities there. Either it can be register interference or input output reference instruction. Okay, so finally here again we are going to decide. Here we are confirmed that D7 is 1. So now if I is 0, it is the register reference. If I is 1, it is the input output instruction. So when I is 0, then finally again it will execute register reference instruction, and after that again sequence counter set to be cleared during the time cycle T3. Similarly here, if it is input output instruction, then again it will execute the input output instruction, and again sequence counter set to be the clear, set to the 0. Again it will start the time cycle T0. So here what we are seeing, it went to the time cycle T0, T1, T2, T3. So here execution takes place. So again, sequence counter is set to clear. Again, it has to start with the time cycle T0. Like this, it will go. And sequence counter can be go up to the time cycle of 15, 0 to 15. So now we have register reference instruction. So in case of register reference instruction, what we have seen earlier, that D7 must be 1 and I dash should be 0. So I dash not should be 0. What we have seen, I should be 0. So that is written here as the I dash. So this combination shows that here D7 is 1, I dash shows that it is 0, and T3 is the clock cycle. Okay, T3 clock cycle. So that is available here. So finally, this is common to the all register reference that is denoted by the R. Now 0 to 11th bit of the instruction register is denoted by the BI. So for the different combination of the BI, it has different, so total how many combination is that? 12 can be obtained. So at a time only one BI will be active. So that's why it's written here B11. R is common to all. Along with this condition, it will satisfy the BI value. So when B11, it is the clear the accumulators. CLE again, we have cleared the E register. Okay. CME complement, CIR circular right, CIL circular left, INC is the increment of the accumulator, SP is the skip for the positive, SN is skip if negative, A for accumulator, SZ if it is 0, accumulator contents is 0, SG is if this bit register E is the 0, HLT is for the halt or stop. So like here if you see, again, for the particular combination of the BI, that is 0 to 11th bit, different instruction, register instruction will be performed here. That is shown here with the help of different notifications here. So these are the discussion, okay, about how this register reference instruction is going to work. So if accumulator is positive, when it will be positive? If 15-bit of accumulator is going to be the 0. So accumulator is the 16-bit registers. So here again, if that is shows that all flip-flops of registers are 0. If AC is negative, that means 15-bit is what 1, and HLT means it's to stop, start. Okay, to stop the start flip-flop and stops counting. So that is the meaning of halt. So again, in such type of the instruction you can see in the microprocessor and the microcontroller also. So if you have any doubt, please write in the comment, as well as you can write in the chat box. Okay. So these are the discussion about how instruction cycle is going to work. We have fetch, decode, and execute. And after that, we have seen register reference instructions.